Ever wonder what's next in the ongoing battle for AI dominance between Nvidia and OpenAI? Well, Nvidia seems to be upping the ante with their latest endeavor, the Gear Lab, short for Generalist Embodied Agent Research. But what's the big deal, you ask? Well, it's all about solving a monumental challenge, unifying the solutions for everything from self-driving cars to robots like Tesla's Optimus, not to mention the usual artificial general intelligence reasoning, through the concept of foundation agents. These cutting-edge entities promise to revolutionize the field by offering a single, unified solution to a myriad of AI challenges. But where does this leave OpenAI? Stay tuned to find out what new possibilities foundation agents might unlock and how Nvidia is positioning itself as a formidable competitor in the race for AI supremacy. So, to start with, what in the world is a foundation agent, and why is it causing such a stir in the AI community? Well, let me break it down for you. Nvidia recently shook things up by launching an AI lab dedicated to creating foundation agents. What's even more eyebrow-raising is that one of the co-founders of this lab is none other than the first intern of OpenAI, Jim Fan, who's now a researcher at Nvidia. Talk about a full-circle moment. So, what exactly is a foundation agent? Think of it as a super smart AI model that's not just stuck in one virtual or physical environment, but can hop around and thrive in all sorts of settings. Picture this. While ChatGPT might be like a person glued to a keyboard, a foundation agent is like a full-fledged individual living their best life. And get this, they can even switch between different bodies and worlds, learning all sorts of skills along the way. Now, in building the foundation agent, Jim Fan and his team had to scale the agents on 3 axes. One of these axes is skills, which refers to the sheer number of tasks these agents can tackle. From playing video games like Minecraft to who knows what else, the foundation agents are jacks of all trades. Next, we've got embodiments. This is all about the variety of body forms these agents can control. So whether they're maneuvering through a virtual world or navigating the physical realm, they're ready to adapt. Last but not least, we've got realities. This is where things get really mind-bending. We're talking about the number of worlds, both virtual and real, that these agents can master. From simulations to actual real-world scenarios with their own unique rules, this axis allows the agents to be the ultimate reality-hopping pros. Now, why should we care about having just one foundation agent instead of a bunch of smaller models? Well, think of it like this. Remember the old saying, Jack of all trades, master of none? Turns out, with foundation agents, it's more like Jack of all trades, master of everything. By combining skills, embodiments, and realities into one powerhouse AI, we're tapping into a level of AI prowess that's truly next level. That means we would move from the era of conventional robots that are only restricted to a fixed set of actions to an era where an AI model can learn new skills by itself, as seen in Nvidia's Voyager. Voyager is an open-ended embodied agent that uses large language models like GPT-4 to interact with and learn from the environment in the game Minecraft. It's designed to explore the world, acquire skills, and make discoveries autonomously. But how does it pull this off? Well, let me break it down for you. First off, Voyager doesn't need someone holding its hand through every task. It's got what's called an automatic curriculum, which the agent creates for itself. Think of it like a self-created super smart guide that helps Voyager explore its environment to the max. This means it's not just sticking to a fixed set of actions. It's constantly learning and adapting, all on its own. Voyager also comes equipped with a skill library that's always growing. This library is like a treasure trove of pre-written code for all sorts of complex behaviors. And again, like the curriculum, Voyager develops this skill library by itself. So, whether it's learning to drive or fold clothes, Voyager can just reach into its metaphorical toolbox and pull out the right skills for the job. Now, here's where things get really interesting. Voyager isn't just flying blind. It's got this cool, iterative prompting mechanism that's like having a built-in feedback loop. This mechanism helps Voyager learn from its mistakes, refine its actions, and make better decisions over time. As I mentioned earlier, Voyager has been putting its skills to the test by playing games like Minecraft. But this isn't just mindless gaming, it's serious AI training. Voyager can explore virtual worlds for hours, adapt to different situations, and even fend off monsters and find food all on its own. And get this, it's using the power of GPT-4 to write code in JavaScript, which it then executes in the game. If there's a hiccup along the way, GPT-4 swoops in to debug the code and make sure Voyager stays on track. Essentially, Voyager exists between the planes of skill and reality on the three axes of the Foundation agent, learning and applying many skills while still being restricted to one reality: Minecraft. With projects like Voyager, it is clear that Nvidia is pushing the envelope and beating OpenAI at AI development. But if there is anything we know about OpenAI, it is that the company won't be twiddling its thumbs while Nvidia steals the spotlight. So you guessed that right. OpenAI has some tricks up its sleeves too. Recently, OpenAI and Figure teamed up to create a humanoid robot named Figure 1, and it's seriously impressive. At its core, Figure 1 operates on an end-to-end neural network, granting it autonomy without the need for direct human control. This means the robot can learn from its environment and react to it independently, similar to a self-driving car navigating the streets on its own. One of the standout features that OpenAI and Figure managed to get right with Figure 1 is its multimodal model, which enables it to understand both images and text. Equipped with cameras and microphones, the robot can process visual and auditory information, allowing it to analyze its surroundings comprehensively. This capability extends to visual reasoning, where the robot demonstrates an understanding of its environment beyond simple object recognition. For instance, it can infer logical conclusions, such as placing dirty dishes in a drying rack after use, showcasing its capacity for nuanced decision-making. Moreover, Figure 1 is equipped with a text-to-speech system, enabling it to respond to humans using natural language. This feature facilitates real-time conversations and explanations of its actions in plain English, enhancing its ability to interact effectively with humans.
On it. So I gave you the apple because it's the only edible item I could provide you with from the table.
In terms of physical capabilities, Figure 1 boasts a whole-body controller that ensures stability and safety during movement. With precise control mechanisms and 24 degrees of freedom in its hands, the robot exhibits impressive dexterity in object manipulation tasks. Its neural network-based visual processing enables it to interpret images swiftly and determine appropriate actions, showcasing its agility and adaptability in various scenarios. Figure 1's decision-making processes are guided by high-level thinking, incorporating common-sense reasoning and short-term memory. This allows the robot to reflect on past interactions and actions and make informed decisions about how to interact with its environment in the future. The mind-blowing thing is that everything you saw in the demo, from picking up objects to answering questions, was done in real time, with no speeding up or scripted movements. So, ideally, one could say that OpenAI is stepping up to the challenge from Nvidia. But here's where you'd be wrong. Unlike Voyager, the Figure 1 humanoid doesn't learn anything that it isn't explicitly asked to learn. It just sits there until it is told to do something. Compare that to Voyager, who is like a person on a mission. When it runs into obstacles it has never seen before, it will invent creative new solutions to overcome them. Now that's smart. As if to show more of its dominance, Nvidia's foray into foundation agents could also solve one of the most pressing problems in robotics. In the world of robotics, different body forms are available, from wheeled machines to those with hands, feet, and various body structures. This raises a crucial question. How can artificial intelligence effectively control such a multitude of robotic designs? This is where another project that Jim Fan co-developed, Metamorph, comes in. Remember how I mentioned that Voyager exists between the planes of skill and reality, but racks up more on skills and is stuck in one reality? Well, Metamorph exists between the two planes of reality and embodiments. And as you can already guess, it racks up more on the embodiment scale than reality. So essentially, Metamorph is an ingenious solution enabling AI to master the control of any robot, regardless of its physical configuration. Traditionally, robots were trained for specific tasks on specific designs. But Metamorph changes the game by using transformer-based approaches to create a universal controller. This means the AI can adapt to control robots with different shapes and sizes, opening up a whole new world of possibilities in robotics. But Nvidia doesn't stop there on their quest to build foundation agents. They introduce Eureka, an AI agent capable of teaching robots complex skills autonomously. By crafting reward algorithms, Eureka trains robots to accomplish an array of tasks, from pen-spinning tricks to intricate manipulations, surpassing human-written reward programs on over 80% of tasks. Empowered by the GPT-4 large language model, Eureka's self-improving nature and integration with Nvidia's GPU-accelerated simulation platform, Isaac Sim, propel advancements in reinforcement learning, unlocking new realms of robotic capabilities. But Eureka is not the only agent supported by Nvidia's Isaac Sim. The platform is also the support behind Metamorph. This sophisticated robotics simulation platform powered by Omniverse offers realistic simulations with GPU-accelerated physics, photorealistic rendering, and modular architecture for diverse applications. Isaac Sim also provides a seamless environment for designing, testing, and training AI-based robots. Its connectivity and interoperability features further enhance collaboration and innovation in the robotics community. With Nvidia's relentless pursuit of innovation and investment in research, the horizon for AI-controlled robotics appears boundless. The potential to train AI on a myriad of body types and scenarios promises a future where any robot we design is merely another iteration in a vast continuum of possibilities that the foundation agent knows how to handle. The question is, will OpenAI ever be able to catch up in the world that Nvidia is about to build? To dive deeper into Nvidia's transformative vision, explore our "Is Nvidia the Next Apple?" video.